Hello, this is Mr. Flatness, and today's lesson will be reviewing adding and subtracting fractions and mixed numbers. Also in our goals today we'll be subtracting fractions where we would have to rename or borrow. In looking at the steps on how to add and subtract fractions, the first thing we need to do is find the least common denominator, LCD, of the fractions if they have ones that are different. So when you look at our three examples here, notice that all denominators are different. Secondly, we need to rename those fractions once we've found the least common denominator, and then we will either add or subtract. We will also be adding and subtracting whole numbers in the case of our mixed number examples. The final step to any adding or subtracting of fractions would be to simplify any fractions that are not in lowest terms. So in our first example we have 5/8 plus 1/4. Looking at our denominators, they are not alike, 8 and 4. And the thing about adding and subtracting fractions is simply this. We need to add and subtract numbers that are the same size as far as size of a piece. So when you're talking fractions, if I have one whole pizza divided into 8 equal slices and then another whole pizza divided into 4 equal slices, we're not talking about the same size pieces. So what we want to do in fractions by coming up with a common denominator is now I'm adding or subtracting the same size piece. So that's the basic understanding about adding and subtracting fractions. So in order to do that, I need to use my skills that I learned in finding the least common multiple. So when I look at the numbers 8 and 4, I know that the LCM, the least common multiple, would be 8. I could also use another just common multiple. A lot of students just take 8 times 4 is 32, and they use 32 as their common denominator. I like to use the lowest common denominator because that way it saves time when I have to simplify my fraction at the end. So, taking a look at that, I need to now rename the fractions. So, if I have fourths and I want to turn them into eighths, 1/4 would be the same thing as 2/8, because 4 times 2 is 8, and so whatever I multiply the denominator by, I have to multiply the numerator by, and that's how I get the 2/8. In the next example, or the top one, I have 8 times 1 is 8, so I multiply 5 times 1 in my numerator to get 5. The last step then would be to add the numerators together, or subtract. In this case we're adding, so 5 plus 2 would give me 7. And then I keep the same denominator, which is 8. So that would be 5/8 plus 2/8 is 7/8. And then I finally look to simplify, and a fraction is in simplest form if I cannot divide both numbers, numerator and denominator, by a factor other than 1. So if you might recall the lesson back on greatest common factors, if my GCF of the numerator and denominator is 1, then I know the fraction is in simplest terms. So the only number I can divide 7 and 8 by is 1, and that doesn't change the fraction at all. It's still 7/8. So that would be the correct answer in simplest form. Our next example has 4/5 minus 1/6. Again, I have different denominators, so I'm going to rewrite by getting a common denominator. In this case I like, again, the lowest common denominator. So when I look at the numbers 6 and 5, I know that the least common denominator would be 30. So I'm going to rewrite my denominators as 30. Okay, so then to rewrite the new numerators, 6 times 5 is 30, so 1 times 5 is 5. 5 times 6 is 30, so 4 times 6 would be 24. Looking at my operation, I need to subtract. So 24 take away 5 would be 19 over 30. Looking at simplifying it, I can't simplify it because the only number that's a factor of both 19 and 30 is 1, so that keeps 19/30ths in simplest form. The final problem we have is 6 3/5 plus 4 7/10. Looking at the denominators, I know that the least common denominator will be 10, looking at the numbers 5 and 10. So then I will rewrite my numerators. 10 times 1 is 10, so 7 times 1 is 7. 5 times 2 is 10, so 3 times 2 is 6. I'll add the numerators together. 6 plus 7 is 13. And then I keep the same denominator of 10. Oh, I have to subtract here. No, I'm adding. Never mind. And then 6 plus 4 would give me 10. So taking a look at this, 10 and 13/10, I see here that 13/10 is an improper fraction. And an improper fraction is when you have a bigger number over a smaller number. And also an improper fraction we know is that this fraction 13/10 is more than 1. I know that 10/10, if I were to have that fraction, any number over itself is 1 whole. So I have 13/10. So I have 10/10 plus another 3/10 to get my 13/10. So basically I can write my 10/10 as 1, and then this 3/10 that's left over becomes the mixed number part, 1 3/10. So I can take a look at taking the whole number 1, adding it to this whole number 10 to get 11, and 3/10 then would be the fractional part. So 11 3/10 would be your final answer after you simplify it. Another way to take 13/10 and turn that into a mixed number is to simply divide. Again, 13/10 is the same thing as saying 13, this line in the fraction means divided by 10. So 13 divided by 10 can be rewritten like this, 13 divided by 10. In doing so, then I know that 10 goes into 13 once. 1 times 10 is 10. I subtract and I get 3. My numerator, which is 3, so here's my remainder, which is 3. That becomes my numerator. And then my divisor, which was here, that just stays as my denominator here. So that's how you take another way to take 13/10 and turn it into 1 3/10. Either way is fine. To me, this is more in your head, and you can do that quickly. But some fractions take a little bit more time, and you can't think of them in your head, so therefore you just do it with long division. Here is an example where I need to subtract fractions by renaming, and also another word to talk about that would be borrowing. So basically when you rename, you're subtracting mixed numbers. We'll have to rename the first mixed number so that I can subtract the fractions. So taking a look at my problem, 6 1/6 minus 3 2/3. I will notice here, first of all, that I have 6 and 3, which are different denominators. First step I want to do is get a common denominator. And my lowest common denominator, 6 and 3, those two numbers, I know that the least common multiple of those two would be 6. 6 is a factor of 6, and 3 is also a factor of 6, so that's how I know. So now rename it. 3 times 2 is 6, so 2 times 2 is 4. So I'm saying basically that 2/3 again and 4/6 is the exact same number, just written differently. And then 1/6 will stay the same, 1/6. So now I have a new problem, or it's not a new problem, but it's just written differently. So now it becomes 6 1/6, and now I want to subtract 3 4/6. Now that I have the common denominator, remember the next step is just to subtract numerators. Well, 4 take away 1, I cannot do. I cannot take 4 from 1. So that's where borrowing comes into play. So I need to take and borrow 1 from the 6, so that makes that 5. So here's this 1 that I borrowed. And what I need to do is add it to the 1/6. So in doing so, I'm going to rewrite this 1 as 6/6. And I'm doing that because I want to have the same denominator. I chose to write 6/6 because here I have the fraction 1/6. So now I can add those two together. I can add the 1/6 plus 6/6, and that would give me 7/6. And then this 4/6 that was on the bottom number, I'm going to just rewrite over here. Now I can subtract. 7 take away 4 is 3. Keep my same denominator of 6. And then 5 minus 3 would give me 2. Final step, I would need to simplify. 3/6 is the same thing as the fraction 1/2. Divide them both by 3. So 2 and 1/2 is my simplified answer. Here are 3 more examples that I'm going to go through with you. If you notice in example 1, we have 8 minus 5 1/8. So I'm going to rewrite it vertically. 8 minus 5 1/8. This problem confuses students at times, or some students I should say, because what they will do is, mistakenly, they will look at, well, there's no fraction next to the eighth, so then they think 1/8 minus 0 is 1/8, and then they take 8 minus 5 and they say that's 3, and 3 1/8 is their answer. Well, this is incorrect in thinking. And I know that because if I added 5 1/8 plus 3 1/8, that does not equal 8. So what I need to do then is do this problem differently. When you have problems like this, what we still need to do is use the concept of borrowing. I need to borrow 1 from the 8 and make that 7. And so now that 1 whole, and I'll put that over here, here's the 1 that I borrowed from the 8. I'm going to rewrite that as 8/8. Now I chose 8/8 this time. If you remember the first time we did it in the last example, I used 6/6. Well, I'm using 8/8 here because my denominator is 8 down here that I want to subtract from it. So 8/8 minus 1/8 would give me 7/8, and 7 take away 5 is 2. I'll look to simplify, and I know, hey, I need to divide by the greatest common factor. Well, the only factor that 7 and 8 have in common is 1. So I know then that that's in simplest form. So 2 and 7/8 is my answer. Try the next 2 on your own. Do them first, then press pause, and then you can see my solutions. Common denominator of 6 and 4 would be 12. 4 times 3 is 12, so 3 times 3 is 9. 6 times 2 is 12, so 1 times 2 is 2. Can't take 9 away from 2, so I'm going to borrow. Again, I remember 4 times 3, so I took that times 3. 6 times 2, so I took that times 2. Borrow 1 from the 8, make that a 7. I'm going to add to this 12/12. That's the 1 whole I borrowed, making 14/12. Then I'm going to subtract from it the 9/12 that I had. 14/12 minus 9/12 is going to give me 5/12. And 7 take away 6 is 1. So my answer, 1 and 5/12, is correct. 4 and 7/8 plus 12 and 2/3, common denominator, would be 24. New numerators, 8 times 3 is 24, so 7 times 3 is 21. 3 times 8 is 24, so 2 times 8 is 16. We're adding this time. 21 plus 16 is 37 over 24. Improper fraction. So to do this, I'm going to use long division. 37 divided by 24. Remember, top number goes on the inside, bottom number goes on the outside. 24 goes into 37 once, 1 times 24 is 24. I'll subtract and I get 13. My remainder is my numerator. 24 stays my denominator. So 37 24ths is 1 and 13 24ths. I'll add whole numbers. 12 plus 4 would give me 16. So 16 plus 1. 16 plus 1 gives me 17. And then I'll keep 13 over 24 as my final answer. And that is also in simplest form. The GCF, again, remember I want to divide by the GCF. Well, 1 is the GCF of 13 and 24, therefore it's in simplest form. Our last slide is a real-world problem application slide. So just taking a look at when you would add or subtract fractions. Here's a case. Kara buys 30 3/4 yards of blue ribbon, 41 1/2 yards of gold ribbon. How many more yards of gold ribbon than blue ribbon did she buy? So this key phrase, how many more, if you go back to your list, when we went through the problem solving examples in the recording that I gave you, how many more is a key word or words that mean subtract. So I want to subtract 41 1/2 and 30 3/4. Go ahead and press pause, solve it, and then press play and see if you solved it correctly. Change the fractions to like denominators. We have denominator of 4, 2 and 4 have 4. That becomes 3/4, and that would be 2/4. Cannot take 3 from 2, so I need to borrow. So I'll borrow from the 41 and make that 40. And I'll add to it 4/4. Next I will add it up. 2/4 plus 4/4 would give me 6/4. And then I'll take away 3/4. 6/4 take away 3/4 would be 3/4. And 40 take away 30 would be 10. Look to see if I can simplify. 3/4. Can't divide them by anything other than 1. Therefore 10 3/4. And here we would have to need a label. We're talking about 10 3/4 yards of ribbon. Then I will just check to make sure my answer is correct. Looking at this, we roughly have 40 and 30. So 40 take away 30 is 10, and my answer is right around 10, so I know that my answer is acceptable. This concludes the lesson on adding and subtracting fractions and mixed numbers.